just in case you needed one more example of how we can do the chain rule with trig, I decided to make one more video looking at what you're going to be asked to do on the test or on an AP test. I think this, combined with all of the other videos that are out there, should help you get a better understanding of everything that could be derived with trig. So what you're looking at right now is you're asked to take the derivative of two terms. These are both chain rule. They are both the same level of chain rule. They're both type 2. You have trig functions to a higher power, but the angle is just x. So we're going to start with the cosine and bring the power out front, take cosine to a power 1 less, and then take the derivative of cosine. The derivative of cosine is negative sine, so you can put the negative in here. If you want, you can just put the negative in front of the whole term. We don't have to worry about the angle because the derivative of the angle is just 1. If the angle was a 2x or 3x, then we have that inner layer that we have to derive, but when the angle is just x, its derivative will always be 1. Then you do the same thing for the second term. You have a subtraction between the two terms. You bring the power out front, take sine to a power 1 less, and then you take the derivative of sine, which is cosine. Again, the angle is just x, so we don't have to worry about its derivative because it would just be 1. I'm going to take the negative that's in the middle of this term and bring it in front. You might have done that right away. So I have a negative 2 cosine x sine x and a negative 2 sine x cosine x. When you see something like this, the first thing that you should notice is these are like terms. It doesn't matter that in the one term cosine is written first and the other term sine is written first because multiplication can be done in any order. I can combine these, negative 2 and a negative 2 give me a negative 4, and then I can either write the sine first or the cosine first. And I actually get a derivative that is a single term answer. If I would ask you to take another derivative of that, I'm not in this case, but you could see that you would have to do a product rule, but you would be working with basic trig functions, no powers, no different angles. The next one, I want to show you this one because there are so many ways you could do it, but I want to make sure you're getting in the habit of doing it the most effective way, the most efficient way, so you're not spending a lot of extra time that doesn't need to be spent. When you look at this problem, you might think about a quotient rule. Hopefully, right after you have that thought, you realize that a quotient rule is not necessary because I can rewrite it. Your options for rewriting it, you could rewrite it with a negative exponent because it is in the bottom, so this is one option. Taking the cotangent, I just put the negative 3 outside so it better illustrates what's going to happen. But there is an even better way of doing this. We did one like this in class, and I mentioned that you really shouldn't have to use negative exponents with trig because you know reciprocal relationships. You should know that cotangent and tangent are reciprocals. So when you have a cotangent on the bottom, it's the same as having a tangent on the top. So an easier way to do this problem is rewrite it from the very beginning as a tangent of 5x being cubed. If you know those reciprocals, cotangent and tangent, sine and cosecant, secant and cosine, it will help a lot of the trig problems. Now it turns into a type 3 trig chain rule. You are going to derive it by bringing the power out front, taking tangent to a power 1 less, so it now becomes the second power. You can put it in parentheses and put the second outside if you'd like. Then you do the derivative of the next layer, which is the derivative of tangent. The derivative of tangent is secant squared. Keep the angle the same. So essentially what you're doing is just deriving this inner piece. And then finally you have to look at the angle, and the derivative of the angle is 5. The only thing that I can combine here are my coefficients, giving me a 15 out front. The other two parts of my derivative are both independent trig functions, and I'm just going to write them down side by side. So this gives you an idea of how rewriting can be very effective even when it's not algebraic, even when it's trig, if you know your basic trig reciprocals. The last problem that I'm going to look at with you, I want to show you how you can take fourth roots. In this case, you have a fourth root of a tangent, and then you have a fourth root of x. Two different fourth roots in different locations, you will derive these differently. First thing I'm going to do is I'm going to rewrite that first term. This tangent of x is under the fourth root, so I want to make sure I write it as a 1/4 power. This tangent is to the first power. What's to the 1/4 power is the angle. So just to have it set apart so you don't confuse it, there I'm going to put parentheses around the angle. That when you see that 1/4 next to it, unless there's parentheses, it is only applying to the angle, not to the entire trig function. So I like this problem because it shows you two almost identical looking terms, and we are going to handle them differently based on the location of the 1/4 power. On the first one, this is a type 2. You have a trig function, basic angle, to a different power. So you're going to bring your power out front, take tangent to a power 1 less, so now it's to the negative 3/4. You can put it there, or you can put it out by parentheses. take the derivative of tangent, which is secant squared, and then it is helpful to think about the angle, but in this case the derivative of the angle is just 1. Plus, now I'm going to go to the second term. This is not a type 2. This is actually only a type 1. Your tangent is just to the first power, so we don't have to do power out front, power 1 less. If you do that, your tangents will disappear, because right now tangent's to the first, so bring a 1 out front, and then it'd be tangent to the 0, which means it is gone. It is just 1. You are just doing a type 1, which means I only have to think about the derivative of the trig function, so the derivative of tangent is secant squared, and the derivative of the angle. And this is just a power rule from the beginning of the chapter. Power out front, power 1 less. Don't have to worry about the derivative of what's inside, because what's inside is just x. Now, a little bit of cleaning up. You don't want to leave negative exponents in your answer. So on this first one, I'm going to keep the secant squared on top, and I'm going to write the 4 and the tangent to the 3/4 on the bottom. Now, if you prefer, you could write it as a cotangent to the 3/4 and put it on the top using those reciprocal relationships. That would be fine. In the second piece, I have this negative exponent I have to get rid of. The secant squared of x to the 1/4 does remain on top. And then on the bottom, you're going to have the 4 from this right here, and then x to the 3/4. 3 problems, all a little bit different. Hopefully now you've seen so many examples. We have this video, we have another video that is strictly trig and chain rule, and then there are other review videos where the trig chain rule kind of gets mixed in with different problems, but it does give you a variety, and I know there's so many different ways that these problems can be presented that the best way is just to practice. So hopefully this practice helped you.